Yeah. Hi guys, let's take a look at this question briefly. If you've been following me on my video on the definition of derivative, I talked about how to define derivative as a rate of change. All right, this is the application of that kind of derivative. Let's have a look at this. Suppose an object is dropped from rest from a given height. The distance s through which the object has dropped after t seconds, ignoring air resistance, is given by the formula. I hope you just know that derivative velocity simply means is the rate of change of distance with respect to time. All right, and once you find the derivative, you find the s, the t of x, that gives you the value for the velocity. All right, let's look at the value for the distance. S is equals to half g t squared. This is the same thing as half, what's g? G is 9.8. all right, 9.8 t squared. If I divide this by 2, I have 4.9 t squared, meaning that s, my distance, the formula is 4.9 t squared. And we're aware that the velocity is ds dt equals to limit as the t tends to 0, right? S of t plus the t minus st over the t. This is the formula of finding the velocity. All right, take it up from here. We have limit here. Let's get our st plus the t. So our st plus the t is equals to 4.9 t plus the t squared. All right, slot it in the what we have here. The s, the t is equals to, take the limit as the t tends to 0. This value here we have 4.9 t plus the t square minus 4.9 t square. Expand this, right? Expand this. Then multiply with 4.9. Simply put t plus the t into t plus the t. If you do that well and multiply by 49 and multiply by 4.9, you arrive at limit as the t tends to 0. We have 4.9, or I can bring it out, bring that value here, 4.9 limit as the t tends to 0. We have t squared, t squared plus 2t the t plus the t square minus t square. This will take care of this. This is plus t square minus t square. We have this as 4.9 limit as the t tends to 0. We have what we have here, 2t the t plus the t square, over the t. Sorry, this is over the t here. If you factor out what is common here, the t, bring it out. we're going to have 4.9, yes, limit. Up here, limit, we have the t, bring it out. Then I have 2t plus the t over the t. This cancel out. I'm left with 4.9. This as the t tends to 0. Yes, I have 4.9 limit. Okay, 4.9 limit as the t tends to 0. This becomes 0. So I have this as times 2t. Right. The t tends to 0. So after the factorization, this becomes 0. So we have this. Therefore, the velocity is equals to 4.9 times 2. That gives us 2 times 4.9. That gives us 9.8 t, which is equals to, what is t? 9.8 t is 2 hours. That is after 2 seconds. What's the final value here? That gives us 19.6 meter per second seconds. That is how you apply derivatives in this kind of question in finding your velocity. I hope you like it. Don't forget to like this. Subscribe for more tutorial on this and hit the notification bell. Thank you.